Hello everyone and welcome back to Mathematics with Usman. This is my fourth video in my series on the topic transformation. And students, today we are going to discuss the third case of transformation, that is called the translation into D. Students, as I told you earlier, there are certain objectives that you have to attain in your transformation topic. There are four cases of transformation: reflection M, rotation R, translation T, enlargement E, and their combinations. Then you have to identify and give precise description of transformation that are connecting different figures. Also, you have to describe transformation by using the coordinates and the matrices. Students, reflection M, rotation R, along with their transformations of coordinates and matrices, we have already discussed in another tutorial, whose link I am going to leave in the description box. Today, we are going to discuss the third case of transformation, that is called translation T. Let us first introduce ourselves with the basic terms that are related with the translation. Students, first of all, understand what does the translation means. Translation means to move or shift a figure with a given translation vector. Means you are given with a vector, you are given with the figure, and you have to shift or move that figure according to the given translation vectors. Means some units in the x direction and some other units in the y direction. Second important thing, students, translation is an isometric kind of transformation. What it means is, whatever the figure you want to translate, its shape and size will always be preserved. There is no change in the size, there is no change in the shape, but it will be displaced or shifted from one point to another. Third important thing that you have to remember is the translation has a very important only one component called the translation vector. Consider you are given with the point having the coordinates x and y written in the column vector form. Then you must have the translation vector t having some x coordinate a and then the y coordinate b. You will add this translation vector to the original point who you want to shift. You will get the image of this point P called P dash having the different coordinates x dash and the y dash, which are the sum of x and a, and y coordinate, which is y dash, is the sum of y and the coordinate of translation vector p. Dear students, let us dig deep into the translation topic of transformation by considering some important examples. Consider a triangle A which is mapped onto B by a translation vector 5, 4. You have to draw and label the triangle B on the given Cartesian plane. Students, see, we are given with the triangle A, which is having its one vertex at -1 and -3, the second vertex at -4 and -3, and the third vertex at -4 and -1. You are given with the second important thing, that is the translation vector, which is moving 5 units in the x direction and 4 units in the positive y direction. And you have to give the triangle B. Let us first consider this vertex of this triangle. We have to translate it 5 units in the x direction and 4 units in the y direction. 5 means you have to move 5 in the positive sense. So students, you will start counting from the vertex. 5 units, 1, 2, 3, 4, 5. So here we are 5 units in the positive sense of x-axis. Now 4 units move in the positive sense of y-axis. 1, 2, 3 and 4. So this should be the image of the triangle A if it is translated with the translation vector of 5, 4. So this is the new position of this vertex. Now let us consider the second vertex. We have to move this vertex 5 units in the positive x direction and 4 units in the positive y direction. So count down 1, 2, 3, 4, 5. 5 units in the x direction, 1, 2, 3 and 4. 4 units in the y direction. So this will be the new position of this second vertex, like this. Now move on to the third vertex. We have to shift it with the same translation vector. Means 5 units, 1, 2, 3, 4, 5 in the x direction, 1, 2, 3 and 4. 4 units in the positive sense. So here we are having the third vertex of this triangle. Now students, this triangle A after translation with the vector 5, 4 will be having its image as B, and the new position of this triangle A as B will be in the first quadrant. Let us now consider the second example. Just consider students a triangle C. This is triangle C is the image of A, means triangle A is mapped onto the triangle C by a translation vector. But the vector is unknown in this case. You have to write down the translation vector for this translation when A is mapped onto C by translation. So students, you have to now consider the corresponding point of triangle A and C. Let us consider this vertex of A, and the corresponding point to this vertex is this vertex of C. You have to see this shift. How many units this coordinate or this vertex of A will move in x direction, and how many units it is moving in the y direction. That will give you the translation vector of your transformation. Now see students, if you consider this point and its image, just consider how many units it is moving in the x direction. So just it is moving 1 unit but in the negative x direction. So minus 1 units in x direction and 1, 2, 3 and 4. Positive 4 units in the y direction. Now consider the second vertex. Again you can see that it is moving negative 1 in x direction and 1, 2, 3, 4 units in the y direction and in the positive sense. Consider the third vertex and you can see clearly it is moving negative 1 in x direction and 1, 2, 3, 4, same as the other vertices in the y direction. So students, translation vector for A that is mapped onto C by translation is minus 1 in x direction and 2 units in the y direction. And students, this brings us to the end of today's tutorial. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.